All right. So here we go. We're live. Mr. Maxstrom, it's Monday all day, 23rd. We're in period 4. Not my favorite class, but, you know. Yeah, not much to look at. All right. Boring. I don't know what you're saying, and I don't care. All right, so here we go. Is that mean for a teacher to say? But, like, I feel that way, like, most of the time when you guys talk to me. It just goes through my head. Just boring. You guys do the same, so it's fair. All right, here's what we got. We know that 1 and 2 are complementary. What does complementary mean? What does complementary mean? Come on. Mr. Mack, you look like Andy Samberg. That's complementary. What else is complementary?
When like both angles add up to 90 degrees.
Yes. Brunderbar. That means wonderful, I believe, in German. They also tell us 2 and 3 are complementary. So we know that 1 plus 2 equals 90 and 2 plus 3 equals 90. We're speaking angles here, of course. We want to prove that angle 1 and angle 3 are congruent. Now, don't get so bogged down with the idea that we need to prove 1 and 3 are the same. Okay? Yeah, we're going to get there. What we really want, what this is really saying, is we need an equation that has 1 and 3 in it. Like, let's get there first, right? Let's get the 2 people in the room before we try to, like, you know, matchmaker, make me a match, right? We don't need to know that they match. We just got to get them in the same room first, okay? If they do match, it'll happen naturally. Isn't that beautiful? Isn't that beautiful? Right? So lovely, right? If 1 and 3 really are the same, if they really are meant to be together, if we just get them in the same room, in the same equation, algebra will take care of the rest. Oh man. That's great. Too bad that's not how that works. But anyway, in math it does. So here we are. 1 I did in blue, 2 I did in green, and 3 I did in pink. So here we are. Equation number 1 I get from this. They're complementary, so they add up to 90. You smell what I'm stepping in? Wonderful. We're not grading this right now. I'm just giving you a little bit of gander, a little bit of taste before we get to number 4, which you'll do on your own. Rest in peace. Number 2. Equation number 2. I numbered my equation so you know which one I'm talking about. Not necessary, but, you know, I'm a teacher. I try to help people out. 2 and 3 are complementary, so that means they add up to 90, right? So I wrote that down. Do I know that this is going to help me? No. I have no idea what I'm doing. I'm not even a real math teacher, right? And that's true. These guys add up to 90 because that's what they told us, right? That's what complementary means. I'm just writing down what I know. Is there any other information I can pull out of the givens? No. That's it. They're complementary. That means they add up to 90. That's all I know, right? So write it down if you know it. Who knows? Might help. That's why people journal. Now, how do I know this? Well, it fits the definition of complementary, right? If it's something where it's like, I don't know what, like, I can't define it, but like I know it when I see it, that's the definition, right? If I showed you this, you'd be like, oh, they add up to 90, they're complementary, right? It's like, well, yeah, because that's the definition of complementary. So by definition, we know this to be true. Is that cool? Story time. In the 80s, I think I might have mentioned this last Friday, but I'm not sure. And if I didn't, I need to get it on YouTube because if they haven't banned me yet, they're going to ban me now. So in the 80s, there was this thing called the Porn Wars, okay? That's P-O-R-N. And it stands for pornography. And they weren't talking about visual. They were talking about musical. So when they were referring to this in the 80s, remember, 80s was a very puritanical time. Congress was concerned. These mostly women. This group went before Congress, and they're like, music is unpure these days, and we have things like Alice Cooper, and it's bad. And so we believe it's pornography rock. And they went before this tribunal in Congress and said, like, we need to ban it. And then artists like Frank Zappa and Alice Cooper and a bunch of others got together and defended their music and saying, no, this is BS, free speech, right? And they compromised, and instead of banning all the music, they just gave it those little labels that say parental warning, right? So the reason I'm bringing this up is because, much like a definition, I don't need you to define it, okay? I just need you to know it when you see it. Now, the guy that was in charge of this congressional tribunal, not a judge, but a congressman, right, just deciding upon this stuff, you know, like the Constitution, which is totally what Congress is supposed to do, not the judicial branch. America's weird. He said, his ruling was, now, I do not know what pornography is when by definition, I cannot define it, but I do know it when I see it. Which I think is a very interesting statement for that man to make. So you just got to know it when you see it. You don't need to be able to define it. You just need to be able to say, look, that adds up to 90, they must be complementary, right? That's by definition. If you ever don't know how to define it, but you just, it's what it is, right? Right by definition, you'll be right 90% of the time. Now, how'd I get to here? Somebody explain that. What? Tie goes in, tie goes out. What? I subtracted what? angle 1 from both sides. That's it. It's just a subtraction property. SUBT, not to be confused with substitution, right? We have two sub-properties. Substitution, subtraction. Got to include the T. So I subtracted angle 1 from both sides. That's it. That's totally cool. You can do that, right? We can do it to both sides. We talked about this forever. Macy wasn't here last week, so I'm going to do it now. Remember, algebra says if you do it to one side, it's child abuse, you can be arrested for it, right? But if you do it to both sides, it's totally cool. It's algebra. You can't be arrested for that. They've tried, but I'm my own lawyer, and I'm good. All right. I won't go back to jail. I won't. They'll never take me alive. All right, so here we are. We're subtracting from both sides. Now what happens? That goes away, and that ends up over there, and we get this, right? Ta-da! Therefore, that's algebra, right? We don't need to write a reason why. It's just how things work in algebra. We subtract from one side, subtract to the other, right? There we go. There's the result. So now we know what angle 2 equals. Now, why did I do this? Like, who cares about that? Well, here's why, you dinguses. Stop writing. Look up here. Take a screenshot at the end, okay? Everything's made up and the points don't matter. Have you not realized that about homework? Everything's made up and the points do not matter. Emphasis on the last bit. You don't need to write this down. I want you to learn. And sometimes it's better to watch instead of write. So check it out. Let's go back up at the top. Notice these two equations. I have an equation with 1 in it, but 3's not in it, right? I have an equation with 3 in it, but 1's not in it. I need an equation that has 1 and 3 in the same room. Well, notice what they have in common. Because that's where the magic all happens, right? That's what they have in common. Well, they have 2 in common. So if I can switch out 2 for a 1, right? Maybe I can make something happen here, right? So I'm going to try and get rid of 2 in one of these equations. Well, how do I get rid of something? Well, I substitute, right? I switch stuff out. Right? If I know that x is 5, I can get rid of x and replace it with 5. And then I'm in business, right? That's how you get your answers. So I'm going to replace 2 with whatever it equals. Well, what does it equal? Well, I found out it equals this, which is a bunch of junk. But more importantly, it equals something with 1 in it. So when I go back here, instead of writing angle 2 plus angle 3, I'm going to write all this junk plus angle 3 equals 90. What does that get me? It gets me an equation that has angle 1 and angle 3 in it, which is what I need eventually, right? Are you smelling what I'm stepping in? I'm going to take this crap. I'm going to put it there. See how they're the same thing? Angle 2 is that, right? If I told you angle 2 is 5, couldn't you take that 5 and plug it in there? Right? I'm telling you angle 2 is all this junk, so plug it in. And what I get is 90 minus angle 1 plus angle 3 equals 90. That's a bunch of mumbo jumbo, but what it means is that I've got angle 1 and angle 3 in the same equation, which is what I eventually need, right? And again, if they're meant to be together, if they really are the same, okay, it'll all work out. So here we go. I'm here. You dig? Angle 2 is this junk. So what I'm going to do with that junk is plug it in wherever I say angle 2. So taking equation 2 now, instead of writing angle 2 plus angle 3 equals 90, I'm going to write that junk plus angle 3 equals 90. There I am. I switched it out. We call that substitution, right? It's what you had when I was gone last week. Macy, you weren't the only one that was absent. My sister had her baby. It's gone. Like, out of her. It's still here, but, you know, we don't have to care about it anymore, which is good. That's how things work, right? Once they're out of the womb, it's like, who cares? All right, so anyway, we're here. Do you see where I'm at and how I got there? Wonderful. Because sometimes I wonder. All right, here we are now. Oh, wait, I ran out of room. Oh, wonderful. You're probably going to have that happen to you, too. That's why I did it on a separate sheet of paper. Also, if you make a mistake, good Lord, yeah, good luck, right? Okay, do it on a separate sheet of paper. So here's what I did. I wrote the same thing twice. That way you could see it again. Do you follow how I got to there? Okay, now I've got an equation with angle 1 and angle 3 in it, right? A bunch of other crap, but, you know, if it's meant to be, it's meant to be, right? So here we go. I'm here. Angle 1 and angle 3 together. Now I'm going to get rid of angle 1 and angle 90 by moving them over. Because, again, I want angle 1 on one side and angle 3 on the other, right? And right now they're on the both on the same side. So I move them over. How do I move 90 over? Subtract it, right? I'm moving the whole 90 over, moving a term over. So I either add or subtract. I'm going to subtract because it's positive, right? Here, that's negative, so I'm going to add it, right? So I did it all in one step. I subtracted and added all together. Also, my pen exploded. Wasn't my fault. And so what happens? Well, 90 and 90 goes away. Angle 1 and angle 1 goes away, right, on this side, and all I get is angle 3. Over here, 90 and 90 also goes away. Oh, that's convenient. And all that's left is angle 1. Aww, they were meant to be. Which means they're congruent. Done. Now here's the deal. They wanted angle 1 on the left side and angle 3 on the right side. See how they're not like that? Technically, that's not correct. So we need to flip them. And the way we flip them is a symmetric property. 2 plus 3 equals 5. 5 equals 2 plus 3, right? Same thing. That's the symmetric property that allows you to do that. Turns out not all numbers work like that, but most of them do. These do. I'm going to walk you through it again, okay? First half. Do you understand how I got there, and do you feel good about it? They're complementary, so they add up to 90. How you feel? Dece so far? Oh, we're too busy writing. We'll take a break. That's why we can't do anything fun. That's why we can't have nice things. All right, so anyway, they're complementary. Hi, Marissa. Which means they add up to 90, right? Ellie, enough. How many different looks do you have? Okay, wonderful. That's not what I was talking about. But I'll be serious now. No, I understand. I understand what you're saying. Right, I understand. So, Ellie, I appreciate the communication. It was effective. So what I'm saying is that we know that they're complementary, right? They gave us that. And complementary means they should add up to 90. So I just wrote that. We good so far? Okay. Now, how do I know that complementary means they add up to 90? Well, that's the definition, right? Right? That's all. So far, so okay? Okay, I'll take okay. I'll take sure. 50%. Now, Ellie, Bailey! Stop. No, we don't encourage people in here. False sense of security. All right. Hi. So Ellie, see the first equation here? I took it and rewrote it down here, but now I'm going to move that 1 over by subtraction. So I subtracted both sides. Still with me? Okay, well, notice that goes away, and what we get is this. Cool? Which I just wrote. That's the result, right? Okay, so far so good. Next thing. I'm going to take the second equation, and I notice that I have angle 2 plus angle 3 equals 90, right? Well, I know angle 2 equals this junk, right? So if I told you angle 2 equals 5 instead of that junk, couldn't you plug in 5 there? Yeah, you could. You get 5 plus angle 3 equals 90, and that would be not good. But, like, we don't know it's 5. We know it's this junk. So I just plugged that in. Do you see how this used to be angle 2? See how I underlined it in green? It used to be angle 2, but now it's this stuff. That's called substitution, right? It's the same dumb crap, so switch it out. Now, why did I do that? I did that because my goal is to get angle 1 and angle 3 together, right? And right now I have two equations, one with angle 1 and angle 2 in it, and another with 2 and 3. I don't have an equation with angle 1 and angle 3. So I got an equation with angle 1 and angle 3. I switched stuff out, right? Now, I don't know if that's going to give me the, I mean, this is proof, who knows, right? But, like, getting them in the same room is a good start to getting them to be together forever. Aww. Now, what happens? You'll notice if I subtract 90 from both sides, it goes away. And if I add that angle 1 over there, then I get angle 3 equals angle 1. Let me show you what I mean by that. So here's what I ended up with, right? If I subtract 90 from both sides, well, that goes away. And if I add angle 1 over, I get this. You dig? I'm not sure why I switched to orange. I think I showed my work with it and I used the wrong color. Which is what we wanted, right? Basically. All I have to rewrite it is like this, and with congruent signs, and then flip these guys. Which we're allowed to do because symmetry. Do you feel better? I'm not asking for 100. I'm asking, do you feel better? Wonderful. And that's a general question for everybody. Put it back when you're done. All right. 2. Number 4, the directions need to be changed because I was tired when I made this, amongst other things. Given angle 1 and angle 2 are supplementary. What does that mean? They're supplementary what, Nellie? They equal 180. So I would write that as a first step after writing the givens, right? Also, I wrote again, and angle 1 and angle 2 are supplementary. That's not what I meant to write. What I meant to write was angle 1 and angle 4 are congruent. So that's fun. This guy and this guy are congruent. That's all that's saying. So you need that. I also tell you 3 and 4 are supplementary. What does it mean to be supplementary again? Add up to 180. So all that information, I'd write that down as the start, right? By definition, 1 and 2 must add up to 180, right? Same thing with 3 and 4. By definition, they must add up to 180. And then from there, you can do some switching around to get 2 and 3 together. This one's harder. There's a lot more switching. But the goal is to try and get 2 and 3 in the same equation. How can you go about it? Don't get overwhelmed by all the numbers. See what they have in common, right? It's good advice in life, too. Don't get overwhelmed by all the numbers, okay? Sometimes it's just a number. Find out what you have in common. Other times it's not just a number, okay? You old. All right, flip the page. Number 5. Direction change. It says A, B, and C are collinear, but it doesn't tell you what A, B, and C are. I put them in. A, B, and C are those dots. D, B, and F are those dots. So all it's saying is that we have 2 lines intersecting. You want to prove that a lot of things. 1 and 3 are the same. 2 and 4 are the same. Right? And you're not allowed to use vertical angles theorem. So here's what I would do. I would say, hey, look, 1 and 2 are a linear pair, aren't they? Right? They're on a line. They're angles that are a pair on a line, right? And linear pair theorem says if they're a linear pair, they must add up to what? 180. They must be supplementary, right? So I know those add up to 180. Well, what about 2 and 3? Are they a linear pair? Yeah, here's the line, right? So they must add up to 180. So 1 and 2 add up to 180, and 2 and 3 add up to 180. What do they have in common again? 1 and 2 add up to 180, and 2 and 3 add up to 180. What do they have in common? Angle 2, right? So we're going to want to switch that one out to get 1 and 3 together. Sound familiar? Okay, watch the video, rewind. I talk about all this stuff, right? And I've said some funny things today. Okay, like and subscribe, leave a comment. Talk about porn wars in here, right? Ban me, YouTube. Ban me, you cowards. How have they not yet? All right. That's that on that for now. The rest is your homework. We've got a problem that I want to take a look at. Here we go. It's a fun one. Grab some graph paper. That's right. Don't touch my graph paper. Oh, thank you. Here, you can have some graph paper. Stop laughing, Hannah. It's a math class, you nerd. It's just math. Oh, man, I wasn't looking in my defense. Sometimes I miss. Yep. Ooh, nice job. You're the Kobe to my Shaq. All right. We're just being so complimentary today. You and me, 90 degrees. All right, speaking of 90, it tells you, given that this angle, TVK, is 90 degrees. Okay. So TVK is 90. Does that mean that these guys are both 45? No, it could be 30 and 60. It could be 1 and 89, right? For all we know, you dingus. Prove that TVX, that one right there, let's color that in blue, because I said so. I like colors. Don't you? Make it easier. Letters are hard. Words are hard, math is easy. And that one's orange. They should be complementary. How do we prove that they are? You add them? Yeah, we do need something with addition. That's a good start. Well, first let's write down what we're given. Given, measure of angle TVK is 90 degrees. And I'm going to write that in red so we remember that it's 90. So how do we prove that those two other angles must add up to 90? What do you think? Too busy writing. Adorable. Think I make you turn this in? I did ask you to get graph paper, I suppose. Should ban all writing utensils in here except for test time. This is a show, guys. It's where the magic happens. All right, so how are we going to prove that these two angles, the blue and the orange, add up to 90? We don't need to know what they equal, right? We don't need to know whether one's 30 or one's 45 or what. We just need to know that they add up to 90. How do we do that? Hannah. Yep, so proof that words are hard and math is easy, that's a V. Blue angle plus orange angle equals 90. How do you know that? Yeah. That ain't gonna cut it. Although, I like how you said it just is. Because that, if it was a thing, if it were, hypothetically, that would be a postulate, right?
Yeah.
Do we have any postulates that allow us to do that type of shit? Or no? Like what? Yeah, angle addition postulate, right? The two little angles add up to the big angle, right? Ellie, what's so funny? So we know that angle TVX, that's a V, Hannah, a V plus the orange angle, KVX. V should equal what angle? TVK. Now, what allows us to say that the two little angles add up to the big one? What's the postulate, Hannah? AAP. Which is 1 R short of American Association of Retired People. Angle addition postulate, right? Okay. So now what? How do I prove they equal 90? I prove they equal that angle. I'm going to have to restate the question, YouTube. They can't listen and write at the same time. I think I've just proven something. That what I was saying earlier is true. You can't learn and write at the same time. Because you can't listen and write at the same time. See, there's a proof within that. I'm playing like 40 chess. You guys are down here playing checkers. All right, so we have this. We prove that they add up to the big angle. But how do we prove they add up to 90? Because that's what I want to do. Because after I know they add up to 90, then by definition they're complementary. I win. Nelly. It is 90. So we switch it out, right? Next step is to switch it. You guys know what bop it is? Don't lie to me. No one is allowed to talk anymore. No more lies. I dare you to find another math teacher like me. I dare you. Now, how was I able to go from there to there? What was the thing I did? What property is that called when I switch something out? Substitution, very good. Thank you, Landry. We call it subs with an S on the end because if it's regular sub, it could be subtraction or substitution, right? So subs property allows me to switch stuff out. Bam, TVK is 90. Therefore, whenever I see TVK, I can switch it out with 90. Now, we're not done. We want to prove they're complementary. Right now, we have an equation. Does that have an equation in it? No. So how do we write that? It's the final step. How do I know that TVK, I'm going to ditch the colors, TVX and KVX are complementary? How do I know that they're complementary given the above information? You just know it when you see it, right? Yeah.
By definition.
By definition, very good. I do not know how to define pornography, but I do know it when I see it. Congressman, on tape. Frank Zappa, the guy who was in the hearing defending his music, later made an album out of that Congress hearing, like sampled that, and the guy's on it. It's great. Great album. It's called Porn Wars Deluxe. Don't Google that. What?
Wasn't there a movie made about that whole?
Probably. I mean, why not, right? It's interesting. It's provocative, right? To say the least. How you feel? Horrible? Did someone say horrible? Yikes. Yikes. See, when I used to work in a school with my mother, who was a guidance counselor, that was interesting. Okay, can you imagine two different people? She's there like, how are your feelings? And I'm just like, ha ha ha, I don't care, right? I got to send people to her. So if you're feeling like that, go talk to someone that cares. Just kidding. I really do care. I'm pretending. All right. I'm pretending. I really do care about you guys secretly. Okay? So. I wish I had like those Google glasses so I could just like take a picture every time you make a face and we could just like put them up on the wall, the many faces of Ellie. And I could have like a chart, be like, oh, confused. That one's really confused. And this one is angry. Okay. Right? Like she mad. All right. Take this home, try it out. Give it a shot. Come in with questions. You need to come in with questions. I don't want answers. Okay? If you got answers, fantastic. God bless you. Okay? Come in with questions. Tell me where you've got stuck. If you're stuck at the beginning, that means you need to come and see me immediately. That was a fun one. That one's going to get uploaded. Concurrent viewers, there's one.